Our next topic is drift velocity. Here we have to consider a metallic conductor AB. The length of the metallic conductor is L and the area of cross section of the metallic conductor is A. This metallic conductor always consists of free electrons. When we apply external electric field to this metallic conductor, the electrons will start to move from the end B to A. The reason is the electrons are negatively charged one, so that it will start to move towards the positive terminal. Here the average velocity with which electrons are drifted under the influence of electric field is only said to be drift velocity. Okay, so drift velocity means the average velocity with which electrons are drifted under the influence of electric field. So here we have to derive the relation of drift velocity. So if we apply a potential difference V across the conductor, the electric field produced in the conductor can be written as E is equal to V by L. Due to this electric field, the electrons are get accelerated, so that the force produced on the conductor can be written as, that is the electric force on electron can be written as F is equal to minus E into E. This relation is similar to the equation F is equal to EQ. So that force on the electron can be written as F is equal to minus E into E. This E represents electric field and small e represents the charge of an electron. If we consider the mass of the electron as m, then the acceleration is written as A is equal to F by m. Then we can apply the value of F, we will get minus E by m. And to calculate drift velocity, we have to use the equation V is equal to U plus A into T. Here the velocity V is taken as the drift velocity and the initial velocity U is equal to 0. And the acceleration A can be written as A is equal to minus E by m. And the time here we are considering as relaxation time. Relaxation time means the average time interval between successive collision of electrons with the atom. So this relaxation time is represented by the letter tau. So that here we get the drift velocity as Vd is equal to minus E by m into tau. If you only consider the magnitude of drift velocity, then we can write this equation as E by m into tau. And we can apply the value of electric field. You will get the relation as V by L E tau by m. This is the equation of drift velocity.
If you found this video helpful, please like, share and subscribe to the channel. See you next class.